Okay. Thanks everyone for joining. Hope everyone had a good holiday season and ready for the meetups to get going again and the conferences and all that. So we're very fortunate to have Cary Hooper with us tonight. I got to see his talk. This is one of the last in-person meetups I got to go to. He gave his talk at DC 214 back, what was that, March or February? Was that March?
It was back in April last year, yeah.
Back in April, so it was like one of the last physical meetups that we had. And he also gave this talk at besides DFW this past year, so we're fortunate to have him. Thanks for joining us, and we look forward to your talk. We've got everyone unmuted so they can ask questions, but some cases, do you want to answer questions as we go along, or do you want to wait till the end of your presentation? Just kind of leave that up to you, so we can kind of direct people. So if you want to make it more interactive, you can do that as well. So
awesome. I've heard we got a really good crowd for these phone school meetups, and I'm really excited to hear y'all's questions. Thanks, Phil, for the introduction. I really appreciate that. My name is Cary Hooper, and we're going to talk about some modern web app vulnerabilities this evening. If you're in the U.S., this morning if you're in Sri Lanka. Thank you all for having me. Thank you, Phil, for having me as well. Quick ground rules. Stop me at any time. Unmute yourself, type in, whether that be any of you or whether that be Phil. Ask me a question at any time. I'd like this to be back and forth. If you don't understand one of the topics or one of the concepts, or I don't explain it that well, there's a high probability that somebody else in the audience also has that question. So go ahead and ask it. I'm not going to pretend to know all of the answers either. So if you know an answer, and I might defer to the audience, or just say we need additional research on that. I don't have all the answers, but I'll give you the best of my ability, and I'll give you the answers from what I've researched. I love meetups like this. Phone school, DC 214. I really like Dallas Hackers as well, and it's really cool that we can all come together, even in these circumstances. Phil, thanks for setting this up, and I think these meetups are important and really cool. So let's get to it. I am Cary. I'm Hoop. You can find me at No Pant Root Dance on Twitter. I'm on a red team for a Fortune 500 company and certifications, and I love building stuff. I got a major house renovation project that we're at least contracting ourselves, so we're doing a lot on our own, and that involves building things and planning. Not just like with my hands, but also like in CAD program and also Python. So the whole purpose and kind of the basis for this project that this talk centers around is that I was a web application pen tester. I'd go in every day, and I'd be doing all the things. I'd be injecting the SQL. I'd be looking for cross-site scripting, OS top 10. And then I'd have to come home and explain things to my significant other, who's totally not technical. I'm sure many of you have the exact same thing. You try to explain something, it's like, oh, okay, that's nice. So I wanted a way to show her what I was doing, and kind of the not just what it looks like when you pop an alert box, but how do you take that one step further? How do you exploit XSS? So I built an HTTP server similar to Apache or Nginx or anything that serves HTTP. I just wrote this in Python, specifically using the Python's Cherry Py framework. This is just a Python package, and my buddy Andy Acer showed me how to work this, and I was able to write some HTML and some Python logic that was susceptible to some of these vulnerabilities. And I had a lot of fun doing this. I had a lot of fun showing this to my significant other as well. I will post these links in the chat during the first demo, so don't feel the need to write all these down. I'll post all the links from the presentation. So this is a web server that I created on GitHub. It's using Cherry Py, using AngularJS and other JavaScript and basic HTML. It's also using a few PDF generating modules. I just really like Python. I think it's a super neat tool. I am not an expert in Python. I think I've taught all the Python I know to myself. I'm sure many of you are in the same boat too. But I'm just now learning how to object orient Python and make it really elegant and kind of build into projects. But this was kind of my first stab at utilizing a framework that I wasn't really familiar with, and it turned out really nicely. This is not built for speed. It's not built to be pretty, but it is built, and it does showcase these vulnerabilities. So what are we going to talk about in this? I promised you at the beginning, modern web application vulnerabilities, on the perimeter. And each of these three different classes of modern web application vulnerability, I've done a deep dive into in the past year and a half. As a web application pen tester, every single day I'd be exposed to, the routine bugs, but then some cutting edge bugs, and some of those cutting edge bugs, I'd do a deep dive and really research and understand how it worked. And then once I did that, I started seeing them everywhere, and it was the weirdest thing. It's like once you learn a word, where you've never heard that word before in your life, but you learn it, and then all of a sudden it starts popping up in books, on TV and everywhere. Same with that. Once I knew what to look for, I started seeing these everywhere, and I thought that was really cool. And I'd like to share that with you all as well. So the first thing is AngularJS template injection, also called client-side template injection, and that results in XSS. Unsafe PDF generation, so that is the server takes in some sort of untrusted input and then creates a PDF out of it, and that can result in everything from SSRF to remote code execution. And then the last is the bootstrap man-in-the-middle vulnerability, which is at least, what is it? It's at least a 10-year-old vulnerability that results from not implementing HSTS correctly. I'll get into that later. And so each of these three classes of web application vulnerabilities kind of correspond to three application trends. One is the reliance on front-end MVC frameworks. I'm sure some of you might have noticed Angular, Vue, React everywhere. There's a real trend over the last 5 years specifically of everything going in that direction. And then the second is the reliance on third-party frameworks or widgets in third-party functionality. It's so easy nowadays for developers just to add another package, to add a third party. Specifically, like you might be developing a Python, and it's wicked easy just to do an import statement or like a pip install. Similar to that, these not only JavaScript frameworks, but also just third-party libraries can be imported. And then last, the network attack surface is shrinking and shrinking, and I think it has been since about 2005. Verizon reported on this in their data breach investigation report. If you look at network web application, or excuse me, network pen tester trends, you'll see like the actual perimeter that's vulnerable is shrinking and shrinking. Therefore, this bootstrap man-in-the-middle vulnerability was a really cool exception to that rule, something that is still exploitable today in 2021, which I think is crazy. We'll get into that. So who's heard of AngularJS? Anybody on the call? I can't see hands. I guess we do have a raise hand feature, but I don't expect you guys to raise them on this call. So let's pretend a few all are raising your hands. I got two. Great. So this is a JavaScript library. It is developed by Google, and it was created by Google in 2010. It's completely open source, and it has one sole purpose. Well, there's many purposes if you ask developers, but from a non-technical standpoint, this makes things look pretty. This extends HTML. You all might know HTML to be specific tags and attributes, but this allows JavaScript to extend that HTML and kind of turn that HTML into an MVC framework. This is not to be confused with Vue or React, which are other front-end frameworks, but it's also interestingly different in a lot of ways to Angular. And we're going to see that on the next slide. So AngularJS and Angular are two different things. They're part of the same project, but there's a clear delimiting back in I forget when, But between version 1.82, which is the last 1.x version, and between Angular 2.0, everything after 2 was then called Angular. And they changed a lot of things, and specifically some what we care about in cybersecurity. They changed the security model. And Angular after version 2 is much more secure. But why do we see so much AngularJS, and why did I, as a web application pen tester, see so much AngularJS? And that's the one reason, because it's so different, because the underlying models are so different. It's relatively difficult to upgrade. When I say difficult to upgrade, I mean you can't just import the upgraded library. It's a completely different framework. Everything breaks, or a lot of things break during upgrade. And what that means to companies is it affects their bottom line. What does it cost me as a development team, in not just terms of man hours or woman hours, but in terms of money? It costs a lot to upgrade. So just like jQuery upgrades, development teams, or specifically the business managers, will opt to utilize the older framework to save on cost. And that's why we still see this everywhere. This is raw code. This is HTML, and there's some JavaScript in here, but bear with me. So what might an AngularJS app look like, and how do we know it's Angular? Let's go next slide. I've got some highlights here. So pay attention to these specific tags. We've got a body. Can you all see my cursor? I'm gonna assume you can. Let's assume. All right, there's ng-app, ng-controller. These are both ways that AngularJS extends HTML. One other clue you might look for is the import, or the script import. There's gonna be some sort of angular.version_number.javascript import, and this might reside on the server itself, or might reside remotely, on a content server, on a third-party server. And then last, there's these references to app.controller and scope.message. These are all references to the model view model framework. Some of you might have heard of MVC. It's kind of a similar to that, but a little bit different, specifically relating to these JavaScript. And then last, it's got the template. And this is one of the cool parts of AngularJS, is that it's got this template defined by the 2 curly Q brackets. And here we have the variable message that's going to be broadcast inside of that H1, or the header. So templates are used to bring those JavaScript objects and put them directly into the DOM, or into the HTML. And so let's talk about template injection. This is a class of attack, but there's 2 different types. Some might have heard of server-side template injection. And so this is when user input is handled unsafely by a server's templating engines. Types of templates may include Twig, JNinja, Velocity, stuff like that. Both of these fall within the A1 or injection category of the OWASP top 10. So now, on the other hand, client-side template injection, this is user input handled unsafely by JavaScript templating engine. And as most of us know, JavaScript is not run on the server side I can't say that anymore, but typically JavaScript is executed in the browser. I have to correct myself, because Node.js is a server-side JavaScript language. But this is handled by the client. This is unsafely handled by the browser. And so the result of server-side template injection could be RCE, remote code execution, if you break out of the sandbox and you're able to execute arbitrary code. However, in client-side template injection, or AngularJS XSS, we have client-side untrusted input, which is JavaScript being injected into the browser. So let's put it all together. AngularJS template injection. So Angular deals with templates. We saw the templates. They had those curly Q brackets around them. Here, there's some sort of expression, which is some sort of object.attribute, and it's templated within those curly Q brackets. Now, this class of attack was created by Mario Heidrich, aka Cure53. It was incepted by him in 2016. Really smart dude. He's not just known for this style of attack. He's actually been huge in the offensive security industry, specifically with these, specifically with cross-site scripting, and specifically with these kind of client-side attacks or DOM manipulation. I'd highly encourage you to look him up and look into his work. So ever since version 1.1.5, AngularJS ran inside a sort of JavaScript sandbox. This is ever since like September 2017. So what does a sandbox mean? A sandbox means that the scope of objects were limited. It means that, that an object over here may or may not have access to, say, the document or the window objects, you know, things that are important to the browser. However, starting with Mario and time again, researchers found a way to bypass that sandbox, to actually take advantage of JavaScript primitives, features of the JavaScript language themselves, and break out of that, to break the parsing logic of the AngularJS language. Some big names are listed here, and on this slide we also have some of those bypasses. The Gareth Hayes specifically, he's working in Portswigger now. Portswigger being the company that created and maintains the Burp Suite, which is a web application pen test tool. Gareth, I'd highly recommend his B-Sides Manchester 2017 talk. It was excellent. If you're interested in this specifically, you should look that up following this presentation. But they kept bypassing and bypassing. The new version would come out, a new bypass would come out. And all of a sudden, we got to version 1.6.0, and Mario Hydrix, it broke it. It used the constructor, which is a JavaScript primitive, the constructor method of a constructor object, and is able to just put an alert within that template. And the AngularJS team did not have an answer for that one. I just want to have an aside real quick during this presentation. JavaScript is so weird. Some of you may know this, some of you may not, but I'd like to reference Brian Heisel's B-Sides 2017 talk, excuse me, B-Sides 2018 talk in Augusta. So he's got a table here of the exclamation point and then 2 square brackets, and then JavaScript, that translates to the Boolean value false. Two empty brackets is an empty array, or as JavaScript may interpret it in some cases, an empty string. The plus is generally addition or string concatenation. However, when you put these two together, the not array and then the empty array, and you add them together, this gets converted to the string false. So a Boolean value false plus an empty array equals a string, which is crazy. There's more. So this equals the string false. Then you can call the constructor, which is a primitive method on that, and then you get a string constructor. And then from that string constructor, within the JavaScript language, you can construct whatever you want. And here he constructs alert document.domain, which will produce a pop-up box with the domain that the pop-up box is on. So JavaScript is so weird that there just seems to be many ways to bypass this. So after Mario came out with that last bypass, in versions of AngularJS greater than 1.6, the sandbox was completely abandoned by Angular developers. In fact, they wrote on their release that input sanitization was the job of the developers, not the job of the framework to prevent. And they just abandoned it altogether. They said, this isn't meant for 100% security in your product. You as the developer need to fix this. They pretty much just said, hey, this is garbage. Let's start again on Angular 2.0, and that's exactly what they did. So I'm gonna do a live demo for y'all with client-side template injection. Are there any questions at this point? I see maybe one in the Q&A. If anyone wants to interrupt me, that's okay. So this is an example of a client-side template injection vulnerable app. This is what the app looks like on the left, and then the source on the right. On the right, notice the ng-app attribute, ng-controller, the import of Angular. There's some references to app.controller. These are all indicative of an Angular application. And also, notice the message down here, and this message is the template that's going to be filled. And the template is defined down here in the third to last line. This is the web server. It's written in CherryPy. It has AngularJS. This is a tool called Wappalizer. It's a extension for Google Chrome, and it's something I really like when I'm doing a web application pen test. It sends some data off to the Wappalizer server, so you have to watch out if you're in a very sensitive environment. If you're DoD and pen testing a DoD network, probably don't want to use this, or anything sensitive for that matter. However, it's for the day-to-day usage, it's really nice for identifying these frameworks and languages. And so this takes in some sort of get parameter, some HTTP get parameter, in this case, hoop, and it reflects it into the page. So given that we know this is AngularJS, how can we exploit this? Let's move on to the demo. All right. There we go. This is the app. Let me make sure I have everything we need. Okay. So we're going to move on to AngularJS. Okay. And I did promise you all some links. I'm going to do that right now. So excuse me. Let's see. How do we get the chat up? Chat to all panelists. Let's paste my message. There we go. Hope that turns out. Okay. So we've got the app. Hello, Pwn School, AngularJS demo app. So we see there's an error. Hoop is not defined. So if we put in a parameter, hoop equals hello world. We see it took that input from the parameter and output into the DOM, right? Hello world. Well, let's just put world. All right. So how might we exploit this? Those of you that have exploited some simple cross-site scripting vulnerabilities, you might say, hey, put in a script tag, right? So let's try that. Let's put in a script tag. Oh, let's script alert 1 and then close the tag. And so on a normal web application, this may or may not work. It depends if the input is being sanitized. So let's see. We successfully put this into the page. However, it doesn't execute. It doesn't treat this as a script tag. And usually when that happens, if you're doing this on pen test, you might infer, but you can also investigate by right-click viewing the source, that the tags, the greater than and less than signs that delimit the HTML tags are being HTML encoded. The ampersand LT colon and the ampersand GT colon. And this is HTML entity encoding, which tells the browser, don't interpret this as a tag, interpret this specifically as that greater than or less than character. So we've got some input sanitization on this page. But we happen to know that it's using AngularJS. And we know that because not only is the Wappalizer telling us, but we have the script import. We see the source code. So we are able to break out of the, do I have Wappalizer? I do. And great, no, never mind. All right, so let's try inputting a template. So I do 2 curly Q brackets, and let's just have, if you're testing for this, one thing that I would recommend is use numbers at first. So we go 6 plus 6. And this has to be a %2b. You need to URL encode this, so it actually interprets that as a plus, not a concatenation or not as a space as it would in the URL. And enter, and I say hello 12. That's not what we put in there. So it's being evaluated. The thing between the curly Q brackets is being evaluated. And that either tells us one of 2 things. We're able to inject some sort of template, but is it server-side template injection or is it client-side template injection? And so we can find out by trying to do Mario Hydrix sandbox escape. Constructor.constructor. No, do I remember this? Let's see. Yep, parenthesis, alert. Hello, Pwn School. Let's see if this works. Crossing my fingers. Look at that. There we go. Give me a round of applause. All right. So we get some JavaScript execution. This is just an alert box. This doesn't mean anything really except that we can execute some sort of JavaScript on the page in the context of this domain. And then we press OK. It executes twice, and then nothing, because there's no actual message that we're putting into the DOM. We're just executing arbitrary JavaScript. So that's kind of a cool way to bypass those character restrictions. Remember, this web application was taking a look for those less than or greater than signs, those tags, and it was specifically HTML encoding them. However, a lot of functions and a lot of frameworks will do this automatically for you. .NET will. What else? PHP, like HTML special char, something like that. It'll automatically do that. But what they don't do is sanitize those curly Q brackets. So if you're using AngularJS or you see an app that has AngularJS, look for this because you'll find it more times than not. I did in actually some very. I found this in a lot of different places, and also in a lot of surprising places where companies were doing everything right. They're big tech companies have their flagship platform, and boom, we found this inside of it. And it's actually really cool. So let's move on. Let's see if I can start this back up. Nope. Great. Let's try this again. Sorry, guys. And there we go. And let's go there. Okay, good. Okay, so this is what we just did. Basically, in this demo, we showed that we could inject characters inside of the DOM, but traditional tags weren't working. So what we were able to do is input a client-side template injection payload, and it worked. So some of you might be developers and thinking, okay, I might use this in my application, but what do we do about it? Well, one of the core principles of web application pen testing is that every single user input must be treated as equal. I'm not just talking about get parameters. I'm not just talking about post parameters. I'm talking about anything that comes from the client, including cookies, user agents, anything in the URL, even if it's past a hashtag, like a hash.location, or any kind of parameter, the host header, everything has to be untrusted. And do not interpret it as something that the application should use unless you sanitize it first, or match it up against a whitelist. AngularJS is very common. It's more common. It will be more common if this is your first time learning about it. If you start looking for it, it's everywhere, and it's just one example of a front-end attack surface. User experience is always going to be king, especially now that we have way more processing power and really these really cool frameworks in the front ends of a lot of websites. And I don't see these front end frameworks going away. I don't see these types of vulnerabilities going away as long as untrusted input is accepted. This will be a problem. So let's move on to the next class of vulnerability, unsafe PDF generation. So computers have been getting faster and faster, especially with the move to the cloud. Server resourcing is not as much of a priority as it was 10, 15 years ago. And what we've seen is web application complexity increasing. And these third-party libraries and frameworks that can just be plug and play are becoming more and more commonplace. But many developers and development teams are relying on these plugins, and adding these in all willy-nilly might result in security bugs. Especially if you don't take if you don't put your black hat on and start thinking about what these vulnerabilities are, or what these features are actually doing. Let me take a pause there. Phil or anyone else, are there any questions about the last class of vulnerabilities before I get into a whole new one? I'd love there to be a back and forth. Or
let me see if there's any questions. One of the questions I had is why do devs love to use a flavor of the week framework?
That sounds rhetorical. And I'm not a dev, so I really can't speak for them. Phil, do you know?
Yeah, it's just I think in my experience over the years, I got my second job in security was application security. In a lot of cases, it's just developers just not understanding how to write code securely. They're just trying to find something that's fast and efficient, does a good job, and especially back then weren't really too concerned with security. And that's really why there's a huge need for the secure coding education and stuff. So that's just more or less an education thing. I don't think they're trying to be insecure, just not knowing how to do things securely.
That reminds me, I've got a couple friends who are front-end web developers. Both work with AngularJS, or at least did back when I was researching these. One worked for Amazon and was formally trained in college as a programmer. I think he went a computer science track, and the other was self-taught. But neither of them had any idea what I was talking about when I started asking about client-side template injection or AngularJS vulnerabilities. And the one that works for Amazon, who's formally trained in college, they said they never taught us this. They never even touched it, which I thought was very interesting because as a pen tester, 100% of my, or specifically a web application pen tester, 100% of my time is like focusing on these web vulnerabilities. So it's just interesting, and I'm sure they have a wealth of knowledge that I'm not trained in. It's really tough. It's tough to cover all your bases, isn't it?
Yeah, it's really the really tough thing is, especially education-wise, on the college level, really trails behind the industry. You know, they're just not there. I mean, you look at Dallas College, where I teach, with formerly Richland College. They started the ethical hacking class back in January of 2018, and then you have some of these schools that teach an ethical hacking class. Maybe they're using Pentest Plus, but the professor doesn't have experience in that area, so they're just regurgitating what they see in the book and not really able to answer questions outside of what's in the book. So,
good point. All right, well, let's move on to unsafe PDF generation. I give an introduction, but let's talk about server-side request forgery. So some of you may have heard of SSRF. I'm not going to ask for hands. It doesn't really work in this virtual environment. But essentially, this is a class of web vulnerability where you, as the client or as the user, you can provoke the web server to make a request. Usually, this is an HTTP request. So if by going out and requesting a page or sending a post request to a server, you can then get it to send an HTTP request to another server, that's probably generally a bad thing. And you can do a lot of different things with that. One of those is you're essentially bypassing a firewall. Usually that server that you're targeting is behind a firewall or in some sort of DMZ, or maybe even in the internal network. And then if it's making an HTTP request, that's unhindered by a firewall. You can also specify a local host address and use it to essentially scan ports on the local machine or the web server itself. If you're having to send an HTTP request to itself on all the different ports, you can analyze the differences between those requests and see which ports are open and which ports are closed. And usually you can infer based off which port number it is, what kind of service is being run on that, which is valuable, specifically if you're going to smuggle protocols. We'll get to that in a bit. And then last, specifically in the cloud, you can access localhost or more importantly, AWS metadata secrets. That's AWS metadata is run on the PIPA address 169.254.169.254. And this was one of the reasons this was one of the ways that the Capital One got breached. In the post-mortem, they wrote about a server-side request forgery in the cloud, gave the attacker or the insider access to to specific secrets that allowed them to escalate privileges within the cloud. And one of the really cool effects is protocol smuggling. I pasted this link already in the chat, so I highly encourage. This is one of the coolest blogs ever. One of the coolest, not just web application pen testers. He's done a lot more. This is Orange Sai, wrote about how he chained 4 vulnerabilities together in order to result in remote code execution. He's talked to Black Hat, talked to DEF CON, and this is one of his images from that write-up. And he was. It's a little complicated, but I think the complication is the beauty of this. So he's able to smuggle a request to localhost, and that's 0. That's gonna the server interpreted that as localhost port 8000, and he found a specific endpoint that was able to send an email via SMTP, and that email was sent to another port on localhost, and he was able to smuggle in marshaled data, and marshaled data caused it. I believe it was a deserialization vulnerability in Ruby, in a Ruby gem. And I just thought that was one of the coolest things ever. This all started with the server-side request forgery. You're not going to find this every day. This also takes an extraordinary amount of talent to find, but I thought it was pretty cool. And let's go back to that presentation. Excuse me. All right, so in DEF CON 27, Ben Sadegapur, aka Namsek, and Sarah Brocious, aka Dakin, they presented on owning the clout with SSRF and PDF generators. I happened to be at this talk, and it really struck a chord with me because I've never really analyzed this attack vector. And it's not a new attack vector. It's actually been around a while, as some of my mentors in my organization reminded me. However, they found this in a bunch of different places. They were able to read the frickin' documentation, read the frickin' manual, and find some really cool ways to exploit this, which we're going to discuss in a little bit. They told the story of how they hacked a ride-sharing app. Untrusted input was then put in, and they were able to inject HTML inside of an automatic PDF generator. And first they found an SSRF within an image tag. They were able to pull an image from a specific domain. Then they also they found a bunch of other bugs. They were able to get a local file include. They were able to access that cloud metadata and take over the entire cloud. I'd highly encourage watching this talk. There's a couple out there, but the DEF CON one is on YouTube right now. So let's talk about PDF generation. PDFs are everywhere. I don't know why, but applications love PDFs, and I guess the users must too, because apps love making PDFs of things. I don't know why. If you look up PDF generation online, you'll see like automatic invoice creators. Within certain forums, such as like Jive forums, you're able to save the forum thread as a PDF. So any of that HTML inside the thread will be interpreted as, you know, HTML by the server, and then you export everything as PDF. So the thing about PDF generation is when it's taking HTML, it's then the server is becoming the client, and by you providing the HTML as the client, you then kind of become the server, and it turns that whole model upside down. And there's a number of different implications because of this. I'm going to give 3 examples of this. One is an HTML renderer, and 2 are headless browsers. You could type in this in Google, and as I did a while ago, it got 242 million results, some of which are probably vulnerable to this. If they're not watching out what their user input is. And remember, user input is evil. So a headless browser versus an HTML renderer. A headless browser is typically a browser without the GUI, and it typically executes JavaScript. An HTML renderer, on the other hand, parses the HTML without that browser engine, and it typically doesn't execute JavaScript. But for both of them, untrusted HTML, client-provided HTML is very bad. And XSS in an app may actually result in JavaScript execution in the server. And think about that one for a bit. The first we're going to discuss is WK-HTML to PDF. This is a tool. It's an open source tool, and all it does is it's a HTML renderer, and it takes that HTML and creates a PDF. Really cool tool. I think it's great. Say you have a nicely formatted invoice in HTML and you just want to print it off and give it to clients, but it's not in PDF format. This will make that into what you need. It utilizes a technology called Qt WebKit, and in our case, what we can do is I've implemented this inside of the vulnerable application, and we can test it by putting in an image tag. And as the server, when it's rendering that PDF, it's going to go out, visit that place where the image is, and then take that image and put it in the PDF. So we're causing it to make an HTTP GET request, and then do something with that request. I'm not going to use the Python user agent server, but I am going to show you a quick demo surrounding this. I'm just going to use Netcat for now. I've got a server and it's running Netcat. It's listening on port 80. Let's go to the same application, PDF gen. And so this is an example of WK-HTML PDF on the back end. We can do any file name, and there we go. I've got a test payload here. I'm just going to copy it in. And all this is just HTML. We've got a header tag. We've got an image tag. We've got an A or anchor tag. And let's submit the query. It's going to take that HTML, it's going to render a PDF, and then we're able to view the PDF. And there it is. Yeah, we got test, welcome to Pwn School. We click the link, we go to pwnschool.com. Awesome. So what if we try to abuse this? And here's one of the ways. So SSRF test. One of the first things in the SSRF methodology in PDF generators, you want to know what you're working with on the back end. Here it's pretty clear that we're working with W8K HTML to PDF. However, in a real life engagement or a bug bounty or something like that, you're not going to know. So what I'm going to do is I'm going to put an image tag with a source equal to a server I control. And this happens to be the same server that is listening in Netcat. So I'm going to hit generate, and as soon as I hit generate, what we're going to see is an HTTP request directly from my Cherry Pie server here to this Netcat port. It's not going to give a response, and that's okay. There we go. Submit the query, and there we've got the full HTTP request. Some of you may recognize this as an HTTP request. We have the GET, which is the HTTP verb. We have the path, or URI. We have the HTTP/version number, but what we're looking at is the user agent. And it looks like a normal user agent until you get down to the right-hand side and you know what to look for. And there in the user agent, it tells us exactly what we have on the back end. This is WK-HTML to PDF, making that request. So we've successfully achieved SSRF against this technology. Let's go back to the slides. So in this example, this is another way of catching the user agent. I just wrote a Python script. In our case, we just use Netcat in order to figure that out. And now we know what's on the back end. Now we know what we're working with. And we've successfully exploited SSRF, which may be a significant issue. So what else can we do? Let's go back and see what other payloads we have. Yeah, we do. Yeah. So one of the things that Sarah Brocious and Ben did, NumSeg did, is they were able to insert an iframe. And HTML and iframe is able to contain things within it. It's really just a delimiter, but one really cool thing is you can contain other websites within it. So if we're able to provide, let's go back. Got it. Hello, Pwn School. Thank you. If we're able to go back, let's see, SRF exfil test, and input an iframe, and we point that iframe to a specific localhost secret. This might be AWS metadata. This might be just a local service that's running, maybe an admin server. In our case, we have a secret on here. And let's change the width and the height so that we can see it. 400 pixels. Width equals, say, 400 pixels. And let's see if that works. So we're making a request to localhost at 31337, which happens to be the same, but it doesn't have to be. And we open, there we go. Yeah, we got an iframe. And we have a message, top secret, unauthorized access not allowed with the secret key. This is just a proof of concept. But we're able to access something that resides on localhost that we didn't necessarily have access to before. This would work if the server was remote as well. All right, moving on. Next up, Weasy Print. So this is a little bit different. This is a rendering engine, also free and open source. This was also a baby kicked in DEF CON 27. Weasy Print is called by their developers, a smart solution for helping web developers to create PDF documents. It's much easier to install in Linux than Windows. I do have this installed in Windows. It is possible, but that's because it takes advantage of a bunch of new GNU libraries. And Windows depends on minimalist new, MingW. Correct me if I'm wrong there, somebody, please. All right, so in this, we're going to do exactly like we did before. Utilize an image tag in order to leak the version of Weasy Print. Exactly like WK-HTML to PDF, we have an SSRF. The user agent is Weasy Print, and it's pretty obvious. Let's do that and then move on to the next demo. And this is something really cool that Ben and Sarah did. So much in the same manner as before, we're going to input an image tag, test. And notice we're using Weasy Print now. This is a different page. We're on the page number 2. So this is using Weasy Print. Test Weasy Print, and let's reset our catcher. Great, thank you. submit, and we caught the user agent. There we go. This particular instance is using Weasy Print 47, but all just the same. Let's continue on. And there's no image because no image was served. However, one of the cooler things that Ben and Sarah did was they read the documentation and were actually able to figure out that a harmless anchor tag could actually result in reading local files off the server. So let's go, let's say Tone School LFI. So let's take a moment to analyze this. We've got two tags here. Give me your secrets. This is just H3 header tag, size 3, and then A, an anchor tag. We say rel equals attachment. And what the server is going to do, specifically what Weasy Print is going to instruct the server to do, is follow this reference link. And instead of the HTTP protocol or any other protocol, we're using the file protocol handler, :// and then a local path, the ctemp admin.log. And this happens to be a file that resides. I'm not going to show you that too, but we'll see. And just the text, this is a harmless link. So let's submit the query. Look at the PDF. And so here's the header. Here's a link, but there doesn't seem to be any file in here. Well, that's because based off the PDF format, the file is actually inside of this PDF. And if we can double click and open this file in Notepad, so it's automatically just in the PDF. We can also use some slick Python to extract it. And let's see if I get lucky with this Python script. There's a Python script, decode.py. I've got it in my GitHub. I can cat it for you guys. But so we got Python decode.py. What do we name it? We named it PwnSchool.pdf. No, PwnSchoolLFI.pdf. So what that script does is it goes through all of the different PDF objects within the PDF. It decodes them using the zlib flate method, and then it tries to see what we have in here. And scrolling up to the top, it goes ahead and spits out this entire log, and this log correlates to that log. And here we show there's some usernames and passwords in here. This is just a SQL log. So this is pretty cool. We've got a local file inclusion. We just put a file from the server using this PDF generation capability, put that file inside a PDF. And of course, we're able to download this PDF over HTTP and decode it locally. So really cool method. I've got some screenshots here. This is the win.ini, for example. All right, number 3. So this last one is Google Chrome. Many people might not know that Chrome can actually be run in headless mode. And ever since Chrome 59, Chrome can be run with the -- headless flag from the command line. This is true for both Windows and Linux. And if you run it with a couple flags, we're able to print a page to PDF. I didn't know how common this was until I started finding these in the wild, and it's surprisingly often Chrome is on the back end. I would say more than 50% of the times that I've seen this, it's Chrome. Maybe that's just the sample size that I've looked at, maybe not, but I'd encourage you to go out and look for these as well. And this is a full headless browser. So if we want to find the user agent, we do it in the same manner as before. Put in an image tag, catch it with the either this Python script or with netcat. Anyway, we have to point it to a server we control. In this case, I'm pointing it to localhost, so it's kind of cheating. But you might have a server in the cloud, you might have a server locally in the DMZ, whatever. So we know this is headless Chrome because the user agent says so. It's a big old tattletale. And let's go a little further first. Okay, so remember, so we done that, and I could show you that as well, but that wouldn't be very cool. But Chrome is full featured, so like, what else can we do with it? And it turns out we can do some really cool stuff. Remember, we turn the client server model on its head. The server is now the client. So can we get it to execute JavaScript? And we can try this, and let's see. You know what? I'm not comfortable with that payload. Let's just do one. Let's test one. So we'll PDF Gen 3, generate PDF using headless Chrome. How do we know it's headless Chrome? Well, we could test it. Sure. Test. I actually have that. Copy pasted. Submit. Let's go. I've got it 2-second delay, and then yeah, there we go. So we got headless Chrome in the connection. Great. Let's go back. It doesn't get anything in return. So let's go back and let's see if it executes some JavaScript. JS test. So we can just do something simple. We can't really pop an alert box, right? Because PDFs don't really have. They do have the ability to pop an alert box, but I'd strongly recommend against it. You can't really do much with it because the SANDBOX within the PDF. First off, I'm not going to get into that this time, but I'd love to discuss after within some questions. So let's just talk about document.write component, and we'll close the tag. Let's see if this works. Submit. Wait 2 seconds because I've got the wait. Otherwise, a race condition occurs. Download, and we've got right there. We can try some other nifty payloads. You can try making HTTP requests. You can try just writing a bunch of stuff, and you can try DOS. Let's see what a DOS might look like. JS DOS. Enter HTML here. That's fine. Here I've got a little payload. We've got a script tag, 2 script tags, and then everything in between is JavaScript. We define a string, and then do a for loop that goes from 1 to whatever 1024 times 1024 is, and then it just appends that to a string, makes a huge string, and then it writes the whole thing to the document. You can submit that, and that'll DOS it. The CPU will be pretty high for the next good amount of time. You know, I don't actually think I have that saved. No, I don't. But we can check back on that in a little bit, and we'll see how long it takes. Let's go back to the presentation. So we can write arbitrary things. That means we can execute arbitrary JavaScript. Remember, we're executing JavaScript on the server, not the client. You can also use the request interface of the Fetch API. There's a link. I set the link in the chat. This is one of my favorites to use. And all this does is request an internal resource and then does something with that. What you can do is request an internal resource and then maybe post that data to a server you control, maybe a Burp Collaborator server, maybe something else. And we create a request object. We fetch that object, and then we do something with the response. In this case, we return it, and then we can write it to the PDF. We can exfil it via DNS, you know, whatever you want. So there are some limitations to this. If you're causing Chrome or any other full-featured backend headless browser to make an HTTP request, there's this thing called the same origin policy. If we were in person right now, I'd ask how many of y'all have heard of the same origin policy, because it's actually extremely important when it comes to the web security model. I didn't, even before my first web application pen test job. They asked me a question about it in the interview, and I just stared. I stared ahead like a cow in headlights. It was terrible. Then I looked it up, and I still didn't know what it was after reading the Wikipedia article. It took me a while to actually internalize what this is. But let's talk about the origin first. So an origin is a scheme or protocol combined with a host name combined with a port. It's that tuple, that triple of information. And so the same origin policy, it says that JavaScript on host A cannot make requests or otherwise grab resources from host B if they're of a different origin. And that origin is that tuple, the protocol or the scheme, the host name, and the port. So if they're different, the same origin policy is enforced by the browser, preventing things from being taken from one site and exfilled to another. And it's generally a good security mechanism. Now, there are exceptions to the same origin protocol, and the browser processes those exceptions with something called CORS. CORS is cross-origin resource sharing. This is an exception or a relaxation to the same origin policy. There's a number of different headers that relate to this, but the big one that I specifically look for as a pen tester is access control allow origin header. And specifically this says what is or which sites are and are not okay, or maybe all sites are, which sites should not be subject to the same origin policy. There's a number of different CORS misconfigurations that you might look for if you're a web application pen tester. A reflected origin, null origin, or just star. However, the best place to learn these is the Portswigger Web Security Academy. Hands down, one of the best training grounds. It's all free. If you search it on Google, Portswigger Web Security Academy, or portswigger-labs.com. It's some top-notch training material, and it's all free. So if you're interested in these, highly recommend going out there. And huge shout out to Portswigger and Albino Wax for creating those. There's also another way to, I'm not going to get into this, but there's also a way to bypass CORS, to bypass the same origin policy. It's called DNS rebinding. And the high level of DNS rebinding is that using JavaScript, we can overload and flush the DNS cache, and using both a malicious web server or at least some sort of JavaScript execution on the client, and using a DNS server, an evil DNS server that we control, we are able to trick the browser into violating that same origin policy by thinking it's communicating with the same origin, but actually it is not, and it is accessing arbitrary sites. And this allows us access to private networks. It also allows us as an attacker to utilize the victim browser as a complete proxy. So we can route, and there are some frameworks that do this. Singularity, Red Tunnel, there's a few others that are written. And it allows attackers to potentially tunnel all of their traffic through this zombie browser that has been subjected to DNS rebinding and gives them access unfettered into the internal network. Really cool. Kind of a similar concept to Sammy Kampar's slipstreaming, though it's completely different technique that Sammy uses. This is nothing new. It is, in the last few years, as DNS rebinding has become much easier. There's been more open source tools making it faster and easier with a much lower barrier to entry. So this is something to remember that does exist. And I'd highly recommend looking into it because I'm still researching DNS rebinding, and I think it's one of the coolest things. So overall, what is the remediation for this type of vulnerability? How do we fix it? The number one thing is don't trust user input. But instead of creating PDFs on the server side, the server-side code, you can create PDFs within the clients. There's a lot of different JavaScript libraries that you can use. But really, I can't, I'd be stamping my foot up here if I was a teacher giving a test. Do not trust user input. Always sanitize it. Compare it against a whitelist. At a minimum, a blacklist, but blacklists can always be bypassed. So don't trust user input, and you'll generally be fine. All right, any questions about PDF generation, headless browsers, anything like that? Nothing? I'll leave a little time for any questions anybody has, or to catch up with the chat. I haven't actually seen the chat. Okay, we'll keep going. All right, y'all. The last one, and I swear this is the last one, it'll probably be the quickest, is the man-in-the-middle bootstrap vulnerability. And I'm going to discuss the importance of HTTPS inside and out. And by the way, if anyone has a question throughout, please stop me. I don't mind going back a few slides to discuss. All right, so what does a man-in-the-middle look like? Picture it in your mind. Close your eyes. Think about it. What does a man-in-the-middle look like to you? Well, one type of man-in-the-middle is an ARF spoofing attack, and that's where a user on the same LAN kind of fakes that they're the router now, and all the traffic from the victim goes through the bad guy. It might look like a Hack5 pineapple. It might look like your ISP. Your ISP is technically a man-in-the-middle. All of your traffic go through their routers, and they're in the middle of it. A man-in-the-middle also looks like, who knows what this is? Anybody? That's a tough one. I'm gonna assume nobody knows what this is, and I got one in the chat. What is it? Oh, really enjoying this. Great. All right, so this is a HTTPS Oh shoot, I forgot what the name is. It's basically an HTTPS decryption appliance. Deep packet inspection or TLS inspection. This happened to be from the blog of Gigamon, but there's many companies that do this. What they do is at the perimeter of a lot of companies, specifically bigger companies that can afford these things, they will decrypt all HTTPS traffic and they'll re-encrypt it at the perimeter. Really interesting and really cool. So that way they can inspect all of their employees' traffic, not necessarily for monitoring, but more for security. Just so in case you do have malware that's trying to communicate outside, and make sure that they can decrypt the traffic and then make sure that it's not malicious traffic. And then last, this is gonna be your favorite, some of y'all favorite, what's that, FBI and the NSA. There might be legal men in the middle. FBI via a court order or lawful intercept, or the NSA via whatever magic they do. I don't know. Who knows? But they're probably doing it legally. So there's lots of different ways to, there's lots of different threat models out there, and everybody's threat model is different. But there's lots of different ways to have, there's lots of different ways to get in the middle of traffic, specifically HTTP traffic.
So with the NSA or FBI or something like that, it would be a G-man in the middle attack.
I like it. I like that a lot. I'll write that down. I need a pencil. All right, my favorite example is this one. Now this will take a little bit of explaining, but it's one of the coolest things I've ever seen. I've actually pulled off this attack, not live. It was in the OSCE lab for offensive security. This was actually in the OSCE course material, but I think that's defunct now. Anyway, so this is there's an article online, and I posted the link in the chat as well, and I'd highly encourage anybody, actually all of you, to read this after this presentation. This is essentially a walkthrough of a type of attack where an attacker on the outside, I'm going to try to walk y'all through with my mouse. So attacker on the internet, if they're able to communicate with a victim router, there's a couple things they can do. So back, I mean, I know 10 years ago, Cisco was the most popular router for like enterprise routers. I think, I don't know if that's still the same or not, but consider a Cisco router running iOS on the perimeter, a victim router. If that attacker is able to communicate with the SNMP, which is Simple Network Management Protocol service running on that router, what they may be able to do, and remember, sorry, I'm assuming, but some of you may or may not know, SNMP is UDP. What is it, port 161? UDP is a stateless protocol. So this actually allows the attacker to possibly spoof their IP address. So if you can craft a packet and spoof an internal IP address, you may be able to communicate with a victim router's SNMP service. Moreover, those of you who have been in the OSCP lab may know that one of the ways to interact with an SNMP service is by guessing the community string. Community string is kind of like a secret or a password, but what pen testers have found out over the years is the very few organizations change that to something that's not guessable. There's a couple defaults, community, public, and private, that I've heard 75% of the organizations use anyway. Anyway, so with that knowledge and with a spoofed SNMP packet, the attacker is able to basically change the configuration of that router, enable TFTP to their IP only. TFTP is another stateless protocol. It's UDP, and it's a file transfer protocol, UDP port 69. And so after that first crafted packet, they would craft a second packet in order to prompt that Cisco iOS device to download a new configuration from an attacker's controlled TFTP server. And so if any of you have taken CCNA or even messed around with the Cisco iOS router, you're able to do this. Just download an entire new config, replace it, and then reboot the system. And so by changing that configuration, the attacker is able to create a GRE tunnel. Think a GRE tunnel is just an encrypted tunnel, kind of like similar to IPsec. and route all of the victim's traffic for the entire victim organization through an attacker router and through an attacker sniffing computer. And this is just one of the neatest attacks I've ever seen. And every single packet goes through the attacker, and I think that's really cool. This is one of the coolest man-in-the-middle attacks I've ever seen, and this is one of the things that got me interested in this. All right, this attack. Oh yeah, one of the things is this attack was published in 2005. Is it still relevant? I don't know. Based on what I know about Cisco iOS devices and based on what I know about networking, I think it is, but maybe not. Who knows? If anyone does know, if it's not possible anymore due to some reason, let me know. But I think it is, and I think I read an article stating the. Oh, never mind. Sorry, I don't want to. Anyway, let's move on. All right, SSL strip. This is another key to demonstrating how easy a man-in-the-middle attack is. SSL strip was developed by Moxie Marlinspike, and he presented on it in Black Hat 2009. This is at Moxie on Twitter, and this is the same Moxie who I don't know if he create and found the Signal app, but if you have the Signal application on your phone, he's a big reason why. But before he got into end-to-end encryption, he started thinking about how to decrypt HTTPS traffic as a man in the middle. And so he created this tool, SSL strip, to basically act as a proxy, being used in conjunction with ARP spoofing, to be used as a proxy between the victim and their target server. And it takes advantage of a tiny indication in the browser that the site is unencrypted. You know that green lock in the corner of your browser? Well, it might not be locked. And, you might not see that green thing if you're going to a website. And it's just a tiny little indication that it's HTTP, not HTTPS. That's not encrypted. So basically, this tool does a match to replace, and it proxies HTTP traffic between the victim and the attacker, and then it proxies an encrypted traffic between the server and the attacker. And it really just does a match and replace for the domain and for the string HTTPS. It changes links to. It's a really neat tool, and it makes it kind of easy to do a man-in-the-middle attack. This is the type of tool that can do things like flip your friend's images upside down, or there's a bunch of DEF CON talks of people doing silly things with this tool, but there's a bunch of nasty things you can do as well. So HTTP, because it's unencrypted, there's no TLS handshake. It's absolutely trivial to do a man-in-the-middle attack or change requests in route. And I just wanted to demonstrate it with this tool here. So what does an HTTP traffic look like? If we're going to Twitter and we type in twitter.com into the address bar, if we've never been there before, what we're going to see is a GET request. We have, let's see if we have a HTTP verb, in this case it's GET. We have the protocol and the domain, which is the resource or the URI, and then the HTTP protocol and the version. What do we get back? We get back a HTTP response code and a bunch of stuff. They're headers, right? But essentially, headers are just metadata about the HTTP connection. This is metadata from the server to the client. Well, specifically in this, we have 301. We have a location header, which says, oh, this 301 says this site is moved permanently, and the location says this is where it's moved permanently to. And what Twitter's doing is they're redirecting to HTTPS, which is great. Now, in this next request, when our browser sees this, it's going to automatically go to HTTPS. It's going to get that HTTPS resource, and Twitter's going to give a different response this time. And when we curl this website, when we use a client, these are the headers that are returned. Specifically, one header I want to talk about with y'all is strict transport security. And Twitter gives us back a strict transport security : max age equals whatever number that is. But we're going to get into that. So what is strict transport security? Well, HTTP strict transport security, also called HSTS. This is, if you want to read the manual, it's RFC 6797. I actually didn't get into RFCs until about 1.5 years ago when I started working. I guess it was 2 years ago. But I started working in the industry as a pen tester. and I saw weird stuff. I saw weird edge cases. I had to open up the RFC. I'd strongly encourage you at least read a couple paragraphs if you're interested. And if you're doing a deep dive in anything, I'd open up the RFC and try to see what's supposed to happen. And yes, RFCs can be broken. The shoulds, the musts, the cannots, they're not always followed. And it's really interesting to see where. So what is HSTS? Well, per the RFC, it allows sites to declare themselves accessible only via secure connections. So when a browser receives this header back, never again in its lifetime or until the timer runs out, will the browser reach out over an unencrypted channel, or it'll always use HTTPS. So this is the response header. And the next portion is the max age directive. And this is the number of seconds to abide by HTTPS. And this, I think, corresponds to 2 years. It's the number of seconds in 2 years. So for 2 years, upon receiving that header, always use an encrypted method. That means Twitter does not expect to downgrade for another 2 years. And every time you access Twitter, you get this back and it resets the clock. There's a couple other directives, include subdomains, and it's all the subdomains of Twitter. You're going to use encrypted methods, and then a preload, which we'll get into that a little bit later. But the value is preloaded into the browser. So let's discuss HSTS a little bit more. Let's talk about Home Depot. So I've got the browser icon up there. I've got homedepot.com. When you type that into the address bar, one of the things that happens by default in browsers, and I do expect this to change, but in the next 5 or 10 years, but it's still not fixed. The first time you type this into the address bar, it will send an unencrypted connection. So the user visits homedepot.com. They type homedepot.com, enter, and an HTTP request is sent, not an HTTPS one. So it sends a GET request to Home Depot. Home Depot responds, hey, you need to access the encrypted resource. You need to access this over HTTPS. Okay, the browser goes and says, okay, well, give me the secure version of this site. And Home Depot says, hey, here's the secure version of the site. You can go and buy your power tools. Great. So what's wrong with this is that the first request is HTTP. It's unencrypted. And remember, with tools like SSL strip, it's arbitrarily easy for anybody in between you and your target to intercept, modify, or completely hijack that session. And that could be an ISP, that could be a lawful intercept, that could be whoever controls the router at your house, maybe a roommate, maybe a parent, maybe a government, who knows. Let's look at another case study, cdc.gov. So we're gonna look at this twice because it's important. So first request, type cdc.gov into the address bar. You want to see the latest coronavirus news. You want to see how close the vaccine is to get into your town. So the first request is also HTTP, not HTTPS. CDC responds with a redirect to HTTPS encrypted. The browser does an HTTPS get. It tries to get that encrypted version of the resource. But now CDC does something different that is so much better than Home Depot. And what they do is they respond with a 200 OK with that additional header, the HSTS, the HTTP strict transport security header. So why does that matter? Well, when the user returns to that site, anytime in the next year, the user visits, and when they type in cdc.gov into the browser, instead of sending that first unencrypted request, the browser knows. The browser knows because it keeps that HSTS response in its database, and it knows that never again should it go on an unencrypted channel to cdc.gov. And it automatically sends that HTTPS request, and you get that HTTPS response. So they have a perfectly encrypted connection, as best as TLS can do. So that's really interesting, but we can't really get around that first HTTP yet. But at least this will also happen if you open up the browser in private mode, but you'll at least have an unencrypted connection or an encrypted connection in every subsequent request. Let's see. So if we are to demo this, let's open up private mode. So we're going to open up a private browser just to show you off. And if you aren't familiar with browsers developer tools, I'm using Firefox here. I'm going to use Chrome. I think that'll be a little bit better. No, let's change my mind halfway. Let's use Firefox, new private window. So if we are to open up, let's let's start with Home Depot. I use Control-Shift-C, and that opens up developer tools. Specifically within these developer tools, I'm going to click on the network tab, and feel free to follow along if you're at home on your computer. So we open up the network tab and type in homedepot.com, click enter, and we get all the network requests. Scrolling up to the top, we see the first request. And the first request, it has the lock with a cross through it. And we can see, I know it's small font, but we have a GET request to homedepot.com. And the response header is a redirect to the HTTPS version of the site. As we can see in the very next request, we have HTTPS request, an encrypted request. And within all of these headers that it responds with, we get no HSTS header. So let's go to cdc.gov, cdc.gov. Same exact thing. We get an unencrypted request first, which redirects to an encrypted request. But in this one's different. This one includes the strict transport security. So now in the very next request we make to cdc.gov, if we do network, cdc.gov, we see that there is no HTTP request. cdc.gov, let's try one more time just to make sure. Yep, the first request that's on here is HTTPS, and it's fully encrypted. So because it received that header, it makes it safe every other time that we go. Any questions on this before I get to the next case study? All right, let's talk misconfigurations.
Hey, Cary.
Yeah, go ahead.
Is that, I clear cookies and cache whenever I settings when I close the browser. Will that clear that cross session setting? Where's it set at? Where's it saved at?
I believe it's I believe it's a cache. Yeah. So if you clear the cache, it will also clear the HSTS database that's local to your browser.
So I'm doing one thing trying to help myself, but maybe I'm not helping in another way.
Sure, but yes, yeah. I'll get into an even better way to do things later. You're not doing anything wrong. The browser is just doing what it's supposed to do.
Right.
Just know that if you are trying to be, if it depends on your threat model, but if you're trying to be the most secure, then yeah, watch out for that. There are certain browsers. I don't know them off the top of my head. I think the Tor browser might be one of them that enforces HTTPS everywhere. There might be an extension called HTTPS everywhere that you can use. I don't know.
Yep. Cool. Thank you.
Yeah, no problem. Any other questions or comments? Okay, let's get into the next one. Misconfiguration. So Microsoft's on the site and found a misconfiguration there. This is one that I see all the time. And I'd like to highlight this because this is rampant. And it is, I believe it's prevalent because administrators don't understand exactly why this is a big deal. Or they don't understand why it doesn't work because they don't understand HSTS. So at Microsoft.com, if you visit httplive.com in your browser right now, or just type in live.com, you will be redirected to https outlook.live.com/show, and you'll be returned an HSTS header. Now this will pass most security audits or security checks. Probably if you're doing automated vulnerability analysis, you might scan the site and be fine because it says it's returning an HSTS header. However, what's the issue? Think about it for a sec. Why is this an issue for me as the user? All right, well, the strict transport security header is stored by the browser, but it's counted per domain. And it treats live.com differently than outlook.live.com because it's on a per domain basis. So every subsequent request you make to live.com, even though it redirected you to outlook.live.com and provided that strict transport security header, it will make an unencrypted request every time you put that into the browser bar, because live.com has to return that HSTS header in order to be protected on that domain. So perfectly safe behavior would be live.com redirects to an encrypted version of live.com, which redirects to outlook.live.com. That's what we'd like to see. But now everybody in the world who puts live.com into their address bar experiences this and makes that first unencrypted request, which again, arbitrarily easy to man in the middle. To illustrate, type in live.com, first request is HTTPS, you get redirected. Browser visits outlook.live.com, encrypted request is sent with HSTS. And the next time a user visits live.com, boom, we see what's called the bootstrap man in the middle vulnerability. This is in the RFC, and I was so surprised to see this within an RFC. This is a 10-year-old document, and they are describing a vulnerability where the first time you will go to this site, as we've demonstrated in this talk, you will always have HTTP. If you just type it in the browser, if you don't know any better, if you don't know it serves HTTPS. So this describes a situation where the user manually enters or follows a link or to an unknown host using HTTP rather than HTTPS, and an insecure channel is created and is vulnerable to attacks. So bootstrap, like the first time you go somewhere, this is going to happen if you have a new browser, if you clear the cache, if you have private mode, anytime it's your first time visiting a site. This is an issue. So the security architects of the web, probably the great graybeards, they created a solution to this. And yeah, attacks. So this is just outlining the attack scenario with SSL strip. Got it. Okay. I'm not going to demo this. I can demo that at the end if y'all want. But I want to talk about HSTS preload because this is important. And this is something I believe in fully. So HSTS preload is special because these special HST, strict transport security configured sites, can be shipped inside the browser. So instead of having to go out to a server and get returned that per domain strict transport security header, these are inside the browser to begin. You install Google Chrome or Firefox with this list of 100,000 or so sites that are committed to HTTPS and say, hey, don't even try that first HTTP request. But in order to qualify, you must meet certain conditions. You have to include all your subdomains. You have to have safe redirects. Go from HTTP to HTTPS and then any other subdomain you might have. Max age has to be greater than 0, obviously. Usually you should have a sufficiently large max age. 3 million or 30 million is a year or something around there. Got the number in here somewhere. You have to watch out though, because if you do this for your organization or your organization's domain, no HTTP sites will load. If say example.com turns on preload and submits for their site to be preloaded into all browsers as an HSTS site, any HTTP site out of any kind of subdomain will not load. You can access it with curl, but you can't access it with the normal browser. And that even is for internal sites. And that is the real issue. That's the real issue why organizations don't want to use preload, is because they have some HTTP resources on their own domain that are internally only, and they don't want those to break. But in order to be completely safe, in order to protect the users, in order to protect their companies, associates, you really need to be committed to HTTPS everywhere. Preload will completely stop and significantly degrade this kind of attack. Let's look at a browser again. I'm going to open up new private window. So let's look at some preload sites. So let's see. Okay, Control-Shift-C, that opens up developer tools. You can go to the network tab. Sure, let's try Twitter. So twitter.com, is this preloaded? Go to network, and looks like the first request is HTTPS. So yeah, it looks like it works. You can't really go off of these. Let's try my website because I know it's preloaded. hooperlabs.xyz. Got to open up developer tools, open up the network tab, click enter, and the first request is encrypted. All of these are encrypted. Now, if we're not sure, you might want to go to developer tools every single time. You can Google HSTS preload submission list, hstspreload.org. You can search a domain and it'll tell you whether or not you're eligible for preload. Let's see Twitter. Was I right about twitter.com? It's currently preloaded, yeah. Let's see. hooperlabs.xyz. Preloaded. Someone give me another site. Go and spit one out. Anybody? Maybe some in the chat. Let's open that up. NSA.gov. Yeah, let's check that one out. So CDC.gov, as we saw before, there's no preload directive. Even though it does the redirection, it doesn't have that preload word, that preload flag within the HSTS header. Let's try NSA.gov. I think that's it. Yeah, NSA.gov, not preloaded. It doesn't have an include subdomains directive. There's no preload directive. And this is the big one. This is the same error as Microsoft. It's HTTP redirects to www. So the HSTS only applies to www.nsa.gov, not when you just type in nsa.gov into the browser. We can just test that. Let's go nsa.gov. Excuse my typing. Over to the network tab and enter. Gave me a little read. I didn't like that. Anyway, that's gonna be tough to show on live demo. Just failed. Healthcare.gov. Come on, Joe user 47. All right. I don't know why I'm doing. Oh, it's preloaded. Look at that. I don't know why I'm doing this. Oh, sorry, go ahead.
Okta.
All right.
Okta.com.
I'm gonna leave that as a sure. We can all do this though. You guys can all do this in your browser so you can check. So Okta doesn't even have an HSTS header. It looks like. I don't know why I would do that. It might have some downstream HTTP dependencies. Generally not a good idea for these. All right, so the remediation to this bootstrap man-in-the-middle vulnerability is to implement this preload. But also preload means HTTPS everywhere, inside and out. This is important because man-in-the-middle is a prevalent attack. In 2011, it does happen. Not just on a small scale at a Starbucks, but also more on a big scale. It could happen in a compromised router, could happen if they, there's a whole lot of ways. So this preloaded HSTS mitigates many man-in-the-middle threats, and it does so by shipping the browsers with the set list of domains before any HTTP requests are even issued by them. They know which domains to use encrypted requests. Anybody can submit their domain on hstspreload.org. You can submit your personal or your organization's domain. However, you must follow those rules. And all it is requires a single HTTP header and a commitment to HTTPS. And you can successfully protect yourself, but more importantly, protect your users. So this concludes my presentation. I really appreciate all of you for attending. These are 3 classes of vulnerabilities, which I've done a deep dive on, and I really appreciate you taking the time to let me share these with you. If you know a little more about these topics than what I presented, please share with me. I'm always learning. I'm always trying to learn more. Teach me something as well. But for now, I'll just open it up to discussion and questions. If anyone has questions or comments or whatever. I see a bunch of chat. So anyway, thank you all for your time. I'll just leave it up. Thanks.
Yeah, thanks for the presentation. That was awesome, Cary. Yeah, we do have some questions on here. Someone asked, this was back when the previous sections you were going through. Someone said, do you have to have the community string in order to pull off the attack successfully? This is probably back where your network.
Yeah, you do. For SNMP, I think for all the versions too. So this is going to be an attack on the earlier versions of SNMP as well. There's version 1 through 3 was the last one I learned about, and this is, I think it's an attack on the earlier versions of SNMP. And yes, you have to have the community string. It acts as kind of a password, but not as many organizations change that password as you would expect.
Someone asked, have you noticed any trend in some older vulnerabilities and exploits being used years later?
You know what? I don't know about that, Phil. I'd have to defer to you. What do you think?
Yeah, I'd see you running across some older things. You think the stuff would go away, but there still some things linger out there.
Yeah, like struts. Can't get rid of that one. I've seen that, but no examples are coming to my mind. Whoever asked that question, what have you seen? Have you seen anything?
Someone asked also, can a malicious JavaScript clear the HSTS cache?
No, it cannot. That's a really good question. So the JavaScript that runs within the context of the browser, I'm not aware. So when I say no, I just mean I'm not aware. I'm not an expert in JavaScript nor client-side attacks, but my understanding is the JavaScript is sandboxed in such a way that it prevents access to the cache or access to that database. Phil, is that correct?
Yep, sounds correct.
So if you were to exploit maybe a 0-day in the browser to break out of that sandbox, yeah, you might. But there's a lot better things to blow a 0-day on than that.
And had another question here. Can an org have HSTS preload but still use some self-signed certificates internally?
I understand. Yep. Let me think. Can you use preload, but use self-signed certificates? Yes. Yes, absolutely. HSTS doesn't apply to the certificate validation. It just applies to the fact that you have an encrypted channel or not. So yes, absolutely.
That is all the questions. Not seeing anything in the chat that wasn't addressed, but great talk. We appreciate it.
Thanks for having me, Phil. This is a lot of fun. Definitely taking me out of my comfort zone, and it's nice hanging out with some close friends and hackers. You know, especially in this remote.
Yeah.
You know, we're not allowed to go to meetups. You were talking about it earlier, but I appreciate you all coming out. This is really cool.
Yeah, thanks everyone for attending. Thanks again, Cary. And if no